Hello. First note, if you haven't watched the previous video on the derivative, watch that first. Link is in the description. In this mini video, I want to quickly explain the formal definition of the derivative. Displayed on screen is the extremely confusing definition of a derivative. Now don't worry, all the things you see on screen are basically things I have already talked about. This part on the left, df divided by dx, is basically exactly the same as k divided by h, just written in a more fancy way. Next, this lim stands for limit, and this specifies that we want the value of this as h goes to or approaches 0, which is what the arrow in the limit means. Remember, h is never equal to 0, that is why we use this notation. Finally, this last part, ignoring the weird notation, is actually very similar to the derivative we came up with for y equals x squared, right? This is technically where I would end this video, but in case you're a little curious about the notation behind this, stick around. But if you're confused, then I recommend that before you watch this next part, that is if you're curious, that you understand the concepts from the last video. This next part might be a little bit more complicated, so hold tight. The reason why this last part in the definition looks a little different than what we came up with has to do with something called functions. Functions are things that when you give it an input, it spits out an output. They are written in a sort of weird way. You pronounce this f of x. The parentheses do not mean multiplication. This is just the notation for functions. This states that f is the name of the function and that x is the input of it. You don't really see it written just like this, though. You often see it equal to something, typically what it outputs. Let's say this function is equal to 2x. This means that when you give it an input, x, it spits out 2 times that number. If you want to see all possible inputs with their outputs of a function, you can graph it. The way you graph it is that you place the input variable on the x-axis, usually just x. Instead of a y variable, you place the function's output, or just what happens when you place the variable inside the function as the y-axis. Let's use an example. What if this graph represented f of x equals x squared? Doesn't this look exactly the same as the graph of y equals x squared? The equations look very similar, don't they? In fact, they are identical, since f of x and y both represent the y-axis. Remember what I said about y equals x squared. It is that if you know x, then you know y. Well, with a function, it is exactly the same thing. If you know what the value of x is, then you know what the function outputs, or f of x. You can think of y equals x squared, where y is a function of x, where it is equal to whatever x squared is. Now we have all the information to interpret this definition. I'll bring up the diagram of how we came up with k. Now, if we wanted to make this general and work with any function, not just x squared, instead of the point's y-coordinate being itself squared, we can just set it equal to what happens if you input x into any function. I'll let you take a moment to digest what happened. This f of x plus h, if it looks confusing, just means what happens if I put x plus h into the function. Now, instead of k being interpreted as the difference in their y-coordinate, you can interpret k as the difference in the function's output between 2 points. In this case, k is equal to f of x plus h minus f of x, the difference in the function's output between the 2 points. Now, to get the slope, k divided by h, we just replace k with the new general expression, and we get f of x plus h minus f of x, all divided by h. This is the exact expression in the definition. Now I'm going to tackle the first part of the definition, which is very easy. The most important thing you need to know is that the d in front of the letter does not mean multiplication or a function. Interpret both letters together as just a single variable. Now this part is very easy to explain. The df divided by dx is actually the same as k divided by h, where df is k and dx is h. The d in front of the variable means change in. So df means the change in the output of the function f of x, and dx means the change in x, which makes sense. The only difference is that when you see df divided by dx, what you are really saying is that you want the slope when dx approaches 0, which is still what we did last time. All there is to the limit is what I explained before, pretty much nothing else to it. Its actual definition is really complicated, so I won't explain it here. Anyway, that's all there is to the definition of the derivative. As I said before, not really much different to how we went about finding the derivative to y equals x squared. Have a good day, and thanks for watching.